Hi, I'm Umaira Kila binti Zulkarnain with matrix number 63848. This video is a reflection for the assignment 1 of aquatic chemistry. For nitrogen cycle, nitrogen enters the water via precipitation, runoff, or from the atmosphere. The two processes of nitrogen cycles are nitrification and denitrification. Nitrification will occur to convert ammonium to nitrite and nitrogen, whereby denitrification is a process where nitrogen is returned back to the atmosphere. The importance of nitrogen cycles is synthesizing of organic matter by the phytoplankton, but the phytoplankton need biologically available forms of nitrogens to sulfur cycles. Sulfur can dissolve in waters by organic depositions, sedimentations of sulfates and sulfides, and wet depositions of sulfates in the atmosphere. Sulfur can replace oxygen functions in aquatic environments by process of redox. Sulfur also the main ingredients for building of amino acid cycles. Phosphorus mainly found in nature as phosphorus-rich rocks. Phosphates from these rocks are released into the nature through the erosion of the excess phosphate mainly come from mining and fertilizer runoff and eventually gathers in the ocean beds to become sedimentary. One of largest phosphorus store in nature is in the ocean sediments. Phosphorus is one of the limiting nutrients in aquatic ecosystems. Carbon cycles. Ocean remove about half of extra carbon dioxide from the atmosphere. Some of it will become dissolved gas and some of it will become bicarbonate ion in the water. Carbon dioxide from atmosphere will dissolve in surface of waters at oceans. Photosynthesis of phytoplankton will turn carbon into organic matter. Many organisms use that carbon to make calcium carbonate, which is building materials of shells and skeletons. Silicon cycle. Most silicon exists as silicon dioxide in nature. The silicon either will dissolve in the water or will deposit in the ocean floor as siliceous ooze. Siliceous ooze consists mainly of the remains of microscopic sea creatures, mostly diatoms and radioolerians. These diatoms will be consumed by the diatoms also control carbon dioxide concentration as it takes up the dissolved carbon dioxide in the water. Factors controlling saltiness of seawater is upstream runoff, downstream tidal current, precipitations, and ice formation. If precipitation occurs, the saltiness will decrease, and if ice formation occurs, the saltiness will increase. There's two conditions, which is hypersaline and brackish. Hypersalines contain high concentration of sodium chloride and other salts, while brackish water is a water that is mixed with seawater with fresh water. One example of hypersaline conditions is in the Red Sea. The factor contributes to this is low rate of rainfalls, high evaporations, and no streams or river. One example of brackish water is in the Baltic Sea. The factors contribute to this is because low evaporation rate and the total exposure of the sun. Because of the Baltic Sea is located at Arctic oceans, it only receives 24 hours of daylight or night. Importance and problems of solids in aquatic environment. There is three types of solid, which is total solids, dissolved solids, and suspended solids. Total solids is summation of dissolved solids with the suspended solids. Some of the importance are providing for algae growth and nutrient for aquatic organisms. For examples, calcium carbonate is needed for formations of the shells. Problems of solid in aquatic environment is it can change the pH of the water. For example, fish eggs need an optimum pH to hatch successfully.